Okay, grade 11s, we're busy with geometry. So far we have done 4 theorems. What are the 4 theorems? What bisect? Line from the center of the circle to a chord. Where must the chord be? Doesn't matter. But if it's perpendicular, then you'll deduct it bisects. So the theorem says line from the center perpendicular will bisect. The other way around, and you've got to have the correct wording for it, is if I give it bisected, then you will say it's perpendicular. Then your wording will be the line from the center to the center of a chord will be perpendicular. You have to distinguish between those two wordings. Theorem 1. Theorem 2 is what?
The
angle at the center twice the angle at the circumference. And you normally don't miss it when it looks like this, to A and A. Then I showed you different variations on them that you've got to look for to be able to see them. Now if you're looking for them, the first one that's strange is when you do this. When you squish it to the side. It's still an angle at the center, and it's still subtended by, let's call it AB, going to the center, going to the circumference. So that will be double that one still. Because it's a different variation on that one. If you squish it to the side, you've got to look for it, otherwise you might miss it. Or it could even be squished so that it's exactly on top of it. And if you don't look for it, you might miss it again. So that will also be twice that one. They're both subtended still by, let's call it AB again. Going to the center, going to the circumference. And the last one is also one that you will not miss. Because it's the one that if you have an angle at the center, but it goes like squished inside, popped out, then that angle at the center, it will be double the angle at the circumference. So whatever that one is, will be double what this one is. And what is the subtending arc? That huge arc subtends that angle at the center, which is a reflex angle, and it subtends the angle at the circumference. So knowing theorem 2, you've got to search for all the variations in a sum. So when I give you a sum today, you've got to start looking for all these things. That's the method I'm teaching you. Number 3 was a semicircle. Alright, so if you have a diameter, doesn't matter where it is. So in other words, I have to have a center. Mine doesn't look like the center, but I'm telling you it is, then it is. Wherever that angle then goes to the circumference, it'll be 90 degrees. The other way around, somewhere in your life I'm going to tell you that this is 90, so you're going to tell me, man, you know what? Then there could be a circle drawn around it with that being the angle at the circumference and this being the diameter. You're seeing what's going to be happening. Alright, but this is angle at the circumference. We're only just starting. We've got a lot of practice to do. And the last one that I taught you was angles in the same circle segment, or the word that you must say but never write down, bow tie. So if you have, you see the bow tie nicely, but it can be very squished, very skew, like you shouldn't be going out like that with that bow tie. It means that AB subtends angles C and D, and they will be equal in size. But the same thing if you swap your head like this, then CD also subtends for A and for B. Do you see it? If you take your fingers, you go from AB to C, from AB to D. Both subtended by the same arc, and CD goes to B and CD goes to A, so they will also be equal in size, bow tie. But what's the correct wording? Angles in the same circle segment. There's also a variation on that. So say for instance I had them on not an arc but a chord. Then you make a chord like that, and then you'll see when I tear them apart like that, and that little piece is there, and that little piece is there. You see what I've done? I've taken it and I've switched them apart. So in other words, if I take this one and cut it out and paste it there, it'll look like that. You see it happening? So now it's still bow tie. But if you're not looking for it, it doesn't look like a bow tie whatsoever. It's two pieces of things sitting somewhere separate. So if they sit together then, it will make up the bow tie, meaning my angles A and B will be equal to each other. And the reason will not be angles in the same circle segment, but angles in equal circle segments. So you've got to realize that. What will give it away in a sum? When you see two pieces equal to each other, it might not be given equal. Maybe the sum said prove these things are equal, and once it's equal, then there's the possibility of this theorem popping up somewhere. But you have to know them off by heart like this. So here comes theorem number 5 and 6, and you're always going to remember Mrs. van Schalkwyk says 5 and 6. Theorem 5 and 6 is all about cyclic quadrilaterals. Cyclic quadrilaterals. Have you ever heard of a cyclic quadrilateral? What do you think a cyclic quadrilateral is? A quadrilateral has 4 sides. All of the specific ones that you know, like parallelograms and rhombuses and trapeziums, whatever. But as long as it's got 4 sides, it's a quadrilateral. But what will make it a cyclic quadrilateral?
The vertices are at the circle.
Yes, exactly right. Very good. Okay, so if the circle touch all 4 of the points, the vertices, are on the circle circumference, it makes a cyclic quad. Example. So A and B and C and D are all on the circle edges. That makes that quad a cyclic quad. So in other words, all of those sides are chords. AB is a chord, BC is a chord, CD is a chord, and AD is a chord. And I have you writing it down as well. We can talk about concyclic points then. I'm saying that those points are concyclic if they all sit on the cyclic cycle, right? If they're concyclic, they all sit on the same circle edges. Concyclic. The word concyclic means if points lie on the edge of the circle, on the circumference of the circle, then they're called concyclic, because I'm going to ask you something somewhere, and I'm going to ask you, are those 4 points concyclic? And you're going to think, what's she talking about? Unless you know what the word concyclic means. So now let's get to the theorems. If I have a cyclic quad, then what happens? First theorem says that the opposite angles are not equal, supplementary. So example, what will my x that I showed on the sketch be if I tell you that this was, for instance, 80? Then x will be 100, not 80. Because I've just taught you that opposite angles are supplementary, meaning together they add up to 180. And if you don't know the word supplementary, please write that for yourself. They add to 180. And what's the other word that you should actually know? What are complementary angles? They add up to? Yes? 90. Excellent. Complementary angles add up to 90. So somewhere in your life you might hear those words. You've got to know that they add up to 90. It's got nothing to do with this. It's just while we were busy with supplementary, let's learn the word complementary again from grade 8, long ago. So they add up to 80. So if I gave you this sum, it would be worth 2 marks. I'd ask you what x is, and you'd say it's 100. But your reason would be, and lucky for us, we do not write the whole thing. We just write the abbreviation. Alright, so if we figured out that x is equal to 100, it means that the reason therefore is, and now the abbreviation, luckily we don't have to say that whole long thing, we can just say opposite angles of a cyclic quad. And you see me writing cyclic out and not writing cyclic out there, so it's fine. Right, so for theorem number 6, we're still going to be in quadratic, in quads, in cyclic quads, but this time we're going to be busy with the exterior angle. Now an exterior angle of a cyclic quadrilateral, where would be an exterior angle? Exterior exterior angle of a triangle, well, I was going to say, where did you hear it from the first time? You know the exterior angle of a triangle. What do you know about the exterior angle of a triangle?
Equal to the two opposite angles.
Is equal to the sum of the opposite two interior ones. Now, where's the exterior angle? It doesn't matter. As long as it's one of the sides extended. Is that an exterior angle of a triangle? No. It has to be one of the sides extended. It's crucial, guys, because you're going to get to a sum like this, and there's going to be something over there, and you're going to say that's the exterior angle, and you're going to know whether it is or whether it's not. If a line has been extended or not. So, same principle. Exterior angle is one of the sides extended. So, let's make a 30-70 example. This then would have been 100. And there's variations, right? Because you could have first said, well, then I'm short 80 because of the sum of the angles of a triangle. And then it's a straight line. And both kids were right. But if you know the theorem, you might save 20 seconds every time not writing two lines. Are you with me? Now, the exterior angle of a cyclic quad does something different. The exterior angle of a cyclic quad is exactly equal to the opposite interior one. So let's make this 110, just because I can. Okay, so what would x then be? 110, because exterior angle of a cyclic quad is equal to the opposite interior one. You just have to say exterior angle of a cyclic quad. Please note the abbreviations. You have to have the correct ones. You're not a parrot though, but you have to have it correct. Right. So that would be 2 marks. One for knowing it's 110, one for knowing it's the reason. In a nutshell, quick. So when you start off with a sum like we're going to be doing now, you're going to say, okay, man said you need 9 theorems. No, not true yet. At the moment you only have 6. But you're going to have 9. And then you're going to sit there and you're going to look at your sketch and you're going to go through number 1, 2, 3, 4, 5, etc. Something to take into consideration looking at this example. Theorem 1 has to have a chord, a center. There's no center. Maybe DE could be a diameter. If it's not given, you don't say it. Looks can be deceiving. Are you with me? Something can look like, but if they don't give it to you, then it's not given. So we have, if I didn't say anything, basically it means that somewhere there is a midpoint. So that first one can't be there, so I can't even search for it. Angle at the center. I need a center. Number 3, semicircle. I need a center. So out of all of this, do you realize the moment that I don't give you the center of the circle, first 3 are out. And later on there's going to be another one out as well. I need a center. Is the bow tie there though? Where? You see a bow tie? Where? Which one is it? It's this one that I've torn apart, split apart. What gives it away? Those 2 little chords that have been given, equal. Mine don't even look equal, but looks can be deceiving when you're with me. All of your sketches will say sketches or diagrams are not drawn according to scale. So mine can look shorter and look longer. I say it's equal, then it is equal. So if you're looking for the bow tie, first glance it doesn't look like there's any bow tie because we're looking for the bow tie, right? But don't forget about the variation on it, that it can be that one as well. So this angle D here will be the same as angle. But I don't have any one of the 2, so what does that help me now? So now we've got to go into the stuff. Remember that nothing you've ever learned gets erased and you don't need it anymore. You're still going to use interior angles, isosceles triangles, parallel lines, etc., Pythagoras, whatever, ideas. What else has been given?
Angle B is equal to 70 degrees.
Why? Because given, another thing that's been given are these 2. So I have a isosceles triangle, which you can say like bow tie, but you never write that. Okay? The reason is not isosceles triangle. Your angle will be 73, B will be 73 because of angles opposite equal sides. Please guys, very important, they freak out about that at the matric marking. You've got to have that correct, not isosceles triangle, 0. Okay, so once I've got that, and this is also the technique. My sketch, which is all written in blue, yours is written in pencil. Everything you find out, you do in pen, not in pen, in highlight pen, because you're not allowed to use pink and purple and blue and green and whatever in a matric paper, so I'm teaching you from the start. Do it in a highlight. Okay, are you with me? So everything I find out in red, I know they didn't give me, I found it out. So now how can I get to? The questions were B and E and D. I don't even have one of the, oh, I have B at least. Alright, how will I find the others? If I have D, I'll have E. If I have E, I'll have D, because we've already decided they're the same. But how will I do that? Alternate? Where's the parallel lines? Are you hearing what I'm asking?
Yes.
If there were parallel lines, do they look parallel? Even if they do, if it's not given, you can't assume. No assumptions, alright? But something else, let's go through the motions. So now I've got everything and nothing's done. But what am I talking about?
There's no
5 and 6.
Cyclic quad.
Oh, yeah, it is.
5 and 6 are the cyclic quads. Are there cyclic quads?
Yes.
Yes, how many? Just one. Name me?
A, E, F, D.
A, E, F, D, or whatever order you would like to call it. A, E, F, D. So what does that help me?
Opposite E is
Equal to D2.
to D as a whole angle.
Big angle D2, that whole angle, and that whole angle,
Equal.
not equal. They're supplementary. See, you're still getting into this. They're supplementary. So what have you got to go and do to tell me what angle D2 is? Not D, not small d. Angle D2. How will I find D2 first of all?
Interior angles of a triangle.
That will be the interior angles of a
Triangle.
triangle, because I need it. I know that the whole one plus this whole one, not equal, add up to 180. But if I have that one, then I know something short to give me 180. So I first, nobody said I must find D2, I have to find it anyway. And to find it, how would I do that? Interior angles of a triangle, and how much is it? Oh, I think it's 34, just checking up on me. 34 because of interior angles of a triangle. Now guys, it's going to get much more worse than this. And there's going to be a lot of triangles. So please tell me which triangle are we busy with? Interior angles of triangle? It's just good practice. I won't deduct a mark if it's not there. But it's good practice, especially if you're doing something weird and wonderful that the matric markers haven't seen, and you're doing something on a completely different trick. Are you with me? So now that I've got that, can I now find D?
Yes.
It's? How will I find that angle D?
1, 4, 3.
Yeah, I'm seeing you adding. Add, and minus from 180. I just want the answer. I just want the answer. I don't want you to show me how you added them and how you subtracted them from 180. So please give me an answer. And the reason would be what? Why am I subtracting from 180? Because it's opposite angles of a cyclic quad. Every time that you start off with a sum, you're not going to write them because you're going to know them. Okay, all the theorems. How much is it, please?
39.
39. But now, I've got D, and please see what I'm doing here. The question will ask you lots of stuff. Take your highlight pen and go and say, yes, I've done that. Yes, I've done that. Yes, I've done that. What still to be done? Okay, I've done everything, now I'm finished. Otherwise, you might not do E, because you didn't check up again what was all the questions. Because there's going to be a lot. So I'm shorting for angle E. sorry, there's no space. So E will be equal to, do I have to write it equal to small d? It's good practice. To show them the connection. Ma'am, I'm seeing that those two are equal. And they're both 39 because of? What is the reason we said that they are going to be equal? Theorem 4, yes. Angles at the?
Equal circle segment.
Okay, so angles not in the same circle segment, but angles in equal, excellent, circle segments. So basically it's all about, if you have a chord, it'll cut the angle, the circle into a larger segment and a smaller segment. But if that chord is the same, there and there, then this size of segment, and from there, that size of segment will be equal circle segments. Can be tricky, they can deduct a mark. So it's not angles in the same circle segment, it's angles in equal circle segments. Marking this, how many marks?
6.
It could be 8. But for a matric paper, this is not on the level I want you, so it'll only be 4. Then if I give you only 4, because can you see where the 8 is going to be? 1, 2, 3, 4, 5, 6, 7, 8. Every statement you make is worth a mark, and the reason is worth a mark. But now, because it's easy and you're a matric, and I say do the sum for me, I say, I'm just going to give you 4 marks. Where's the marks going to go? Both of those, 1 mark. Both of those, 1 mark, both 1, both 1. So the guy who has no reasons actually has the sum right, but it's going to get
0.
0. You cannot say anything in geometry without giving me a reason. And most often, especially now if you're getting to the more difficult stuff after practicing a lot, you'll see that the marks are done this way. If it's a more difficult theorem, they usually give 1 for the statement, 1 for the theorem. But if it's especially some of the angles of a triangle, that will always just be 1 mark for both of them, the statement and the reason, because it's old news. The more difficult ones, the newer ones, usually 1 each. Okay, but you'll remember that you cannot just write a statement, you have to have a reason. It's tough. If you wrote all of those down for me and I say, 0, you can say, but ma'am, and I'll say, but learner, did I not teach you to write a statement of a reason for everything that you write down? Okay, I'm just going to put your homework up.